So in this example, we're going to bring back some variables. We want to find the numerical value of Tn, the length from T to N over Nr, the length Tr over Nr, and the length Rn over Rt. So we just want to find that numerical value. Now we do know that we have similar triangles. We've got that parallel line in the middle of the big triangle that's dividing it proportionally, dividing the sides proportionally. So therefore, since the sides are being divided proportionally, we know that if I call Tn, the length from T to N, x, then R to N or N to R has to be 2x, because that length has to be proportional to the side on the left. The length RS has to be divided the same way. So since RM is twice as much as MS, RN is going to be twice as much as NT. And then what we could do is we could say the whole thing is 3x, right? Now we don't know the value of x. We're not really asked to find the value of x. And we won't be finding the value of x. Quite frankly, we can't, because x could be anything. But we do know that we've got Tn is going to be x. So let me see, Tn is equal to x, and Nr is equal to 2x. So the x's cancel, and that leaves me, right, when the x's cancel, leaves me 1 over 2. So Tn over Nr, we could also think of it this way. Tn over Nr is the same thing as Sm over Mr, which is equal to 3 over 6, which is equal to 1 over 2. So lots of different ways that we could be thinking about this. Another thing that we call, this is we call it a similarity ratio with respect to the two triangles. If we do something with the 9, if we do something with this 9, okay? So the similarity ratio would not be 1/2. The similarity ratio would be 6 to 9, not 6 to 3, and not 3 to 6. But that's, that's going backwards. I don't want to go backwards here. I'll show you though. So we've got the 6 to 9. So the similarity ratio, I just love how these are all related. The similarity ratio is 6 over 9, which is 2 over 3. When you're dealing with that triangle proportionality theorem, it is not the same thing as the similarity ratio. It's related because you've got that proportion going on. You've got fractions that are equal to each other, but you have to be very, very careful when you're working with these. And you'll see in the homework also, if you check your answers in the homework, you'll see, oh, I can't do that. There's a couple of problems in there. Hopefully you'll make sure that you're really thorough about that, and you'll look out for not making a mistake. So TR over NR. TR is, in my pink over here, here's TR. TR is 3x. So I'm going to show you 3x. And then NR is 2x, right? 2x. And the x's cancel, and we get 3 over 2. So that's this ratio right here. TR over NR is 3 over 2. I kind of like the way I did it with the x, the 2x and the 3x, because it's a little bit faster for me. But they're showing you here the triangle proportionality theorem. So that is what they're showing you. You can also use that triangle proportionality theorem to do what I'm doing with the x and the 2x and the 3x. And then Rn over Rt, 2x over 3x, 2x over 3x is how I get the 2/3 a little bit differently. then they're getting it. But from the same premise. Now here we've got if 3 parallel lines intersect 2 transversals. 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Now we have already talked about this with congruence. So when, I'm going to show you real quick here, when we did this, so let me use my straight lines. We did this, and this was pretty cool. Okay. We said if, right, then that. So what they're saying is, well, hey, if I move this, so I don't have congruence now, right? So these two things aren't congruent. Actually, let me get rid of this. Delete, delete. So that was when we were talking about congruence. Here, this is super cool. If I shift this up now, if I shift this up right here, and I say A, B, and C and D. So this length is A and this length is B. And then I have this length C and this length D. What they're saying is, this corollary says, hey, A over B is going to equal C over D if all 3 lines are parallel. If all 3 lines are parallel. If the lines aren't parallel, then that corollary doesn't come into play. And then the last theorem says, if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other 2 sides. This one's actually a pretty important one too, and I don't want to rush through it. It's only going to take me a few more minutes, but this video has exceeded what I wanted to do, which it's great. It met my goals, but I'm going to come